Hello student, welcome to my channel Learn Physics. Today I will be discussing the MCQ of motion, and this MCQ is from the DC Pandey. I have already uploaded the MCQ of DC Pandey of chapter motion, of chapter dimension, error and vector. You can watch this video clicking the link in the description box. Okay. Now, this MCQ will be extremely helpful for NEET, main, and advanced. Now, let's start. Now, question number one. A packet is released from a rising balloon accelerating upward with an acceleration A. The acceleration of the stone just after the release. When the stone is released from the balloon, its upward acceleration becomes zero. So the stone has only a downward acceleration g due to gravity. So option B is correct. Okay, understood. Next. Now question number 2. A ball is thrown vertically upward from the ground. If T1 and T2 be the respective time taken in going up and coming down, and air resistance is not ignored. Look at this. Look at this, the time of ascent T1, this equal to U divided by the retardation. Retardation, look at this, G downward, and the acceleration due to retarding force also downward. And during falling, that is time of descent, P2 equal to, look at this, U, G is in the downward direction but A in the upward direction. A always directed opposite to the direction of motion. Okay, A always directed opposite to the direction of motion. So look at this from this figure. Look at this. This is greater than this. Therefore, T2 greater than T1. Okay. So time of descent greater than time of ascent. Okay. So look at this. This option is correct. Yes. Now question number 3. The length of a second hand in watch is 1 centimeter. The change in velocity of its tip in 15 seconds is. The change in velocity of its tip in 15 seconds. Now in 15 seconds, the tip moves from, look at this, look at this is the initial position to final position. Okay. Now here velocity along this direction, here velocity along this direction. So change of velocity, look at this, delta V, this is equal to root under of v square plus v square minus 2v into v cos 90 degree, because angle between this velocity and this velocity is 90 degree. Okay, so this is the root 2 into v, no problem. Now the velocity of second hand, look at this, the velocity of look at this, the velocity of second hand root 2 into omega into r. Here root 2 into omega, r is the 1 centimeter, so 1 centimeter. So this is the root 2 into omega. What is omega? Omega is the 2 pi by t. What is the time period of second hand? Time period of second hand is 60 seconds. So look at this. This is the, so look at this. This is the 2 pi by 60. Therefore, this is the, so this is the root 2 pi by 30 centimeter per second is the change of velocity in 15 seconds. Which option is correct? Look at this. Option D is correct. Okay, understood. Next. Now question number 4. A particle moving along a straight line travel half of the distance with uniform speed of 30 meter per second, and remaining half of the distance speed is 60 meter per second, the average speed of the particle. Look at this, here distance same. For same distance, the average velocity is 2 v1 v2 divided by this is the v1 plus v2. Okay, this is the average velocity for same distance. Now this is the 2 into 30 into 60 divided by this is the 30 plus 60. Okay, understood? Now next, look at this. This is the 2 into 30 into this is the 60 divided by 90. Now this and this is the 3, this and t meter per second. Okay, understood? Next. Now question number 5. A boat is moving with a velocity of 3 I cap plus 4 j cap. Look at this. This is the 3 I cap plus 4 j cap with respect to ground. The water in the river is moving with a velocity of 3 cap minus 4 j cap with respect to the ground. The relative velocity of the boat with respect to the water. Now, relative velocity of the boat with respect to water, VBW is equal to, this is the VB minus VW. Look at this, here VB is the 3 I cap plus 4 j cap. Okay, no problem. And VW, this is equal to minus of 3 I cap minus 4 j cap. So look at this becomes 6 I cap plus 8 j cap is the relative velocity of boat with respect to water. Okay, understood? Next. So look at this. So option C is correct. Now question number 6. During the first 18 minutes of a 60-minute trip, a car has an average speed of 11 meter per second. Okay, what should be the average speed of the remaining 42 minutes so that the car having average speed of 21 meter per second for the entire trip? Now look at this, here average speed, look at this, here average speed is 21. So this is the S1 plus S2 divided by T1 plus T2. Total distance, look at this, total distance divided by total time taken. Now look at this is the S1, this is the 11 into 18 into 60 plus, look at this is the V into, this is the 42 into 60 divided by, look at this, total time is 60 into 60. Now this 60, this 60 and this 60 cancel out. So look at this is the 11 into 18 plus V into 42 divided by 60. This equal to 21. Now this is the 42 into V. This equal to, this is the 21 into 60 minus 11 into 18. Okay, look at this. Look at this. If you divide whole expression by 6, so this becomes 7V. Look at this. This is the 21 into 10 minus, look at this, this is the 3 into 11. Okay, so this is the 7V equal to, this is the 177 equal to 7V. So V equal to, look at this, 177 by 7. So look at this is the 2 and this is the almost 5. So this is the 25 point something. Options, look at this is the 25.3 is the correct option. Now question number 7. A particle is moving along a straight line. Its position at any instant is given by x equals to 32t minus 8t cube by 3, where x is in meter t in second. Find the acceleration of the particle at the instant when velocity is 0. That is, particle is at rest. Okay. Now we have to calculate time when velocity is 0. Okay. Now you know, if we differentiate position, we get velocity. If we differentiate velocity, we get acceleration. Now look at this. The velocity v equal to, this is the 32 into 1 minus this is the 8 into this is the 3t square by 3. Now this cancel out. So this is the velocity is the 32 minus 8t square. Okay. Now what is acceleration? Look at this acceleration A equal to this is the dv by dt. Okay. Now look at this here 0 minus 16t is the acceleration at that time t. Now we have to calculate the acceleration when the particle is rest. When the particle is at rest. Now look at this. This is the expression of velocity. The velocity of the particle will be 0 when 32 minus 8t square this equal to 0. So here 8t square this equal to 32, therefore t square equal to 4, so t equal to 2. Okay, understood? Now we have to calculate the acceleration in time t equal to 2 seconds. Now acceleration A equal to this is the minus 16t, so this is the minus 16 into 2, that is minus 32 meter per second square. Look at this, the option B is correct. Okay, understood? Next. Now look at this question number 8. A car starts from rest and accelerates at constant rate in a straight line. In the first second, the car covers a distance of 2 meters. The velocity of the car at the end of second will be. So here look at this, S equals to this is the 2 meter and it starts from rest. So look at this here, U equal to 0. Now look at this here, S equal to this is the half into average velocity, final velocity plus initial velocity into time taken. Now time taken is equal to 1. S equals to this is the 2. So 2 equal to half into V. So V equal to 4 meter. Therefore velocity of the body at the end of 1 second, this is the 4 meter per second. Okay, understood? Next. Now question number 9. A particle is moving along x-axis whose position is varying with time according to the relation x equals to minus 3t plus t cube, where x in meter, t in second. The displacement of the particle for t equal to 1 second to t equal to 3 second each. Okay. Look at this. A particle is moving along x-axis whose position is varying with time according to the relation x equals to minus 3t plus t cube, where x is in meter, t in second. The displacement of the particle for t equal to 1 to t equal to 3 second is. Now look at this. This is the position. Now if we differentiate it, we get velocity. So velocity v equal to this is the dx by dt. If this is the dx by dt, so this is the minus 3 into 1 plus this is the 3 into t square. Okay. Now when v equal to 0, we have to calculate time. So 0 equal to this is the 3 into t square minus 1. Therefore t equal to 1. So velocity becomes 0 at t equal to 1 second. Okay, no problem. Now suppose this is the line of motion. We have to calculate displacement for t equals to 1 to t equal to 3. Now look at this, at t equal to 1 and this is the t equal to 3. If we put t equals to 2, look at this, if we put t equal to here, the velocity is positive. If velocity is positive, so displacement is also positive. Now put the t equal to 1 at this equation and this equation and t equal to 3 in this equation, we get displacement. This is the delta x, this is the x3 minus x1. What is x3? Look at this, if we put 3 in this equation, we get, look at this, minus 3 into 3 minus 9 in plus t cube. So this is the 27. So minus 9 plus 27. So this is the 18. Now if we put t equal to 1, look at this, this is the minus 3 plus 1. So this is the minus 2. Therefore displacement, this is the 18 minus minus 2. So this is the 20 meter. Now, which is the option? Option, look at this. This is the plus 20. Okay, understood. Next, now question number 10. The acceleration of particle increasing linearly with time t is bt. The particle starts from origin with initial velocity v naught, the distance traveled by the particle in time t. Now, first of all, we have to identify the boundary condition, that is initial condition. Look at this. when when t equal to 0, t equal to 0, look at this, s is 0 and v equal to v naught. We have to calculate the displacement. Okay, now now we have to calculate the distance traveled by the particle. Look at this, look at this, this is the acceleration. So look at this, this is the dv by dt, this equal to v into t. Therefore dv, this is the integration, this equal to b e dt. Okay, no problem. Now what is the boundary condition? When t 0, velocity v naught. When t equal to t, velocity is v. So look at this, integration of dv, in this side this becomes v minus v naught, and this is the, look at this, b into, this is the t square by 2. Now limit is t 0. So this is the half b t square. Okay, understood. Now look at this, we get v equal to b naught plus half b t square. This is the velocity. Now we have to calculate displacement. Look at this, velocity v equals to, this is the ds by dt. Now ds by dt equals to v naught plus half b t square. So look at this is the ds integration, this is the v naught, this is the dt integration, plus this is the half b, this is the t square dt also integration. Now limit 0 0, this s0, because when t equal to 0, the displacement is 0. Now look at this is the t, this is the t, this is the s. Now here this is the s minus 0. Look at this is the v naught into t minus 0, and this is the plus half b into t cube by 3. This is the t 0. So s equal to, this is the v naught t plus 1 by 6 bt cube is the distance traveled by the particle. Okay, understood? Option A is correct. Okay, understood? Next. Now question 11. Water drops fall at regular interval from a tap 5 meters above the ground. The third drop is leaving the tap the instant of the first drop touches the ground. How how far above the ground the second drop at that instant? Okay. Now first of all we have to calculate the time of fall. Look at this here, time of fall t equals to, this is the root over 2h by g. Now this is the 2 into h. H means this is the 5, g is the 10. So this is the 1 second is the time of fall. Look at this is the position of third drop, this is the position of second drop, this is the position of, look at this, first drop. So this is in the ground, and this, so its time of fall 1 second, its time of fall, this is the half second, this time of fall is the 0. So we have to calculate the distance traveled by the second drop in half second. So here h equal to, this is the half, g is the 10, t is the 1 by 2 whole square. So look at this is the 10 by 8. So this is the 1.25 is the position of the particle from the top. This option is correct. Okay, understood. Next. Now question number 12. A stone is dropped from the top of a tower, and 1 second later, second stone is thrown vertically downward with a velocity 20 meters per second. The second stone will overtake the first after it traveling a distance of. Look at this. Now look at this. The height fall by the first drop This is the half g t square. Now height drop for the second drop, this is the age rest, this is the 20 into this is the t minus 1. If the time of fall of first is t, second drop throws 1 second, the second drop is thrown 1 second later. So the time of fall of the second stone is t minus 1. This is the plus half g, this is the t minus 1 whole square. Now put the value of h here. So look at this is the half g t square. This is the 20t minus 20. This is the half the g, this is the t square minus 2t plus 1. Okay. Now look at this is the half g t square equal to this is the 20t minus 20 plus this is the half g t square minus, look at this is the 2t into half g. So look at this is the g, so this is the g into t. Now this is the half g into 1, so this is the 5. Okay. Now look at this, half gt square, half gt square cancel out. Therefore we get, look at this is the 20t minus 10t. So this is the 10t. Okay. This is the plus 5 minus 20. So this is the minus 15. So minus 15 is, this is the 15. Therefore t equal to 1.5. Okay. Now distance travel by the first stone in 1.5 second. This is the h equal to half into g is the 10 and t is the 1.5 whole square. Look at this 1.5 whole square, that is the 2.25 and this equal to 5. So this is the 10. So this is the 11.25 is the distance travel by the first stone. So look at this, option C is correct. Understood? Now question number 13. When a ball is thrown vertically up with velocity v0, it reaches the maximum height of h. Look at this, as it reaches the maximum height h, so h equal to, this is the v0 square by 2g. Okay? Now if one wishes to triple the maximum height, then the ball should be thrown with velocity. Now look at this, 3h, this equal to v square by 2g. Now put this h from here. Look at this here, this is the 3 v naught square by 2g equal to v square by 2g. Okay. Next, look at this is the 2g cancel out. So 3 v naught square equal to v square. So look at this, v equal to, this is the root 3 v naught. Okay, understood? Next. Now question number 14. A particle moves in the xy plane with velocity vx equals to 80 minus 2 and vy equals to 2. If it passes through a point x equals to 14 meter and y equal to 4 meter at t equal to 2 second, then the equation of the path. Now what is the boundary condition? Boundary condition when t equal to 2 second, okay, x equal to 14 and y equals to 4. Now first of all look at this is the Vx. Look at this, Vx means dx by dt. So look at this here, dx is equal to, this is the 80 minus 2 into dt. Now integrating, look at this is the dx and this is the 8, this is the t dt, okay, minus 2 dt. Now integrating, the boundary condition 2 when t is 2, x equals to 14. Now this is the t, this is the t, this is the x. So from this equation you can get x minus 14. This is the, look at this, 8 by 2 into t square. Look at this here t 2 minus here 2 into t, here boundary condition t 2. So from this equation you can get, look at this is the 4. Therefore look at this is the x minus 14 equals to 8. This is the 4 t square minus, look at this is the 2 square. 2 square means 4, 4 into 4, this is the minus 16. And look at this is the minus 2, minus 2, minus plus 2, this is the plus 4. Now 16 plus minus 16 plus 4 minus 12, minus 12 minus 14, so this is the minus 2. So you can get x equals to, this is the 4t square minus 2t plus 2. Okay, this is the expression of x in terms of t. Now, if we differentiate this dy by dt equal to t, you get this is the dy by dt, this is the 2. So, this is the dy equal to 2 into dt. Now, integrate. Look at this, the boundary condition when t equal to 2, y is equal to 4. This is the t, this is the y. So, this is the y, this is the 4. Equal to, look at this 2, this is the t, limit of integration, this is the t 2. So look at this y minus 4, this is the 2t minus 4, t cancel out. So t equal to, this is the y by 2. If you put t equals to y by 2 in this equation, we get, look at this is the x equal to 4 into y square by 4, this is the minus 2 into y by 2 plus 2. So we get x equal to, this is the y square minus y plus 2. Which is correct? Look at this, option A is correct. Okay. Now question number 15. The horizontal and vertical displacement of a particle moving along a curved line are given by x equals to 5t and y equal to 2t square plus t, the time after which the velocity vector makes an angle 45 degree with the horizontal. Now look at this, the angle made by the velocity vector with the horizontal tan theta equal to 1045 degree. That means this is the Vy by Vx. Now 1045 degree 1. So here Vy equal to Vx is the necessary condition to find the numerical, to find the time t. Now what is the velocity Vx when x equals to 5t? Look at this, here Vx equals to, this is the 5 into 1. What is the velocity Vy? Look at this is the Vy equal to 2 into 2t plus 1. Because if we differentiate y with respect to time, we get Vy. So look at this is the 40 plus 1. So look at this is the 40 plus 1, this equal to 5. Therefore 40 equal to 4. Therefore t equal to 1 second. So after 1 second, the velocity vector makes an angle 45 degree with the horizontal. Okay, next. Now, question number 16. The height y and distance x along a horizontal plane of a projectile on a certain planet is given by y equal to, this is the 80 minus 5t square and x equals to 60 meter. T is second, the velocity of projection. Now look at this, Vy is equal to, this is the 8 into 1 minus 10t. Okay, so this is the 8 minus 10t. If you compare this, so this is the uy minus gt. So here initial vertical velocity is the 8 and acceleration g is equal to, this is the minus 10. Now we have to calculate Vx. What is Vx? Vx is equal to, look at this is the 6 into 1. So this is the 6 meter per second. So initial velocity along horizontal direction is 6 and initial velocity along vertical direction is 8. So the velocity of projection, this is the 6 square plus 8 square, this is the 10. Okay, which is correct? This is the C option is correct. Okay, understood. Next. Now question number 70. A ball is released from the top of a town. A ball is released from the top of a tower of height h meter. It takes t seconds to reach the ground. What is the position of the ball at t by 3 seconds? Now look at this. H is equal to, this is the half g t square. Now we have to calculate the position at t equal to t by 3. So this is the h dash is equal to half g. This is the t by 3 whole square. So this is the 1 by 9 into half g t square. Okay. So look at this, h dash equal to, this is the h by 9. Okay, so look at this, the distance from the ground, now the distance from the ground, this is the h minus h by 9. So this is the 8 h by 9 meter from the ground is the distance of the particle at time capital T by 3 seconds. Okay, next. Now question number 8. An ant is at a corner of a cubicle room of side A. The ant moves at a constant speed u, the minimum time taken to reach the farthest corner of the cube. Now, now look at this. This is a cubical room. Okay, this, this, and this. Okay. Now the end moves from. Now the shortest part for the room. Look at this. This diagonal plus this height. Okay. So look at this. This diagonal is the root 2 into a plus a. Okay, plus a. So total distance is root 2 plus a. So the time taken by distance by speed. So this is the time. So option D is correct. Okay. A lift starts from rest. Its acceleration is protest against time. When it comes to rest, its height above the starting point. Now look at this. This is the initial acceleration for 2 meter per second square for 4 seconds. Then constant speed. Then retardation. Okay. Now look at this. The distance traveled by the lift during the first 4 seconds. So this is the initial velocity 0. So this is the S1 equals to half into 2 into 4 square. So this is the 16 meter. Now velocity gained by after 4 second. This is the 4 into 2. So this is the 8 meter per second. Now distance travel from 4 second to 8 second. 4 second to 8 second. So this is the 4 second. So 4 into 8. So S2 is equal to, this is the 32 meter. During retardation time 4 second. Retardation is the 2 meter per second square. Initial velocity is the 8. Okay. Now look at this. S3 is the, this is the 8 into 4 minus half into, this is the 2 into, this is the 4 square. This and this cancel out. So look at this. This is the 32 minus, look at this. This is the 16. Now 32 minus 16. So this is the 16 meter. Now 16 meter plus 16 meter, 32 meter plus 32 meter, 64 meter is the distance traveled by the lift. Okay, next. Look at this question number 21. Two objects are moving along the same straight line. They cross a point capital A with an acceleration a and 2a and velocity 2u and u at t equal to 0. The distance moved by the object when one overtakes other. Okay. So look at this. During overtaking, the distance traveled by first equal to distance traveled by second. So look at this. The distance traveled by first. This is the 2u into t plus half into a into t square. This equal to, look at this. This is the u into t plus half into 2a into t square. Now divide whole equation with t. So look at this. This is the 2u minus u. This equals to, this is the at minus half at. So look at this. This is the half at. Now half at equal to u. So t becomes, look at this, t equals to 2u by a. Now distance travel. Now put this value of t in this equation. We get, look at this. This is the S1 or S1 or S2. This equals to 2u into 2u by a plus half into a into 2u by a whole square. Okay, no problem. Look at this. This is the 4u square by a, and this is the 4u square by 2a. So this is the 3 by 2 into 4u square by 4u square by a. Therefore, this is the 6u square by a is the answer. Okay. Look at this. Question number 22. A cart is moving horizontally along a straight line with constant speed 30 meter per second. A particle is to be fired vertically upward from the moving cart in such a way that it returns to the cart at the same point from where it was projected after the cart has moved a distance of 80 meters. At what speed relative to the cart must the projectile be fired? So look at this. When cart moves the distance of 80 meters, the projectile reaches from this point to this point. Okay. Now, first of all, we have to calculate time taken by cart to move 80-meter distance. So this is the distance by speed because it moves with constant speed. This cancel out. So this is the 80 by 3. So this time is the time of flight of this projectile. Now time of flight of this projectile, this is the 8 by 3, this equal to 2u by g. Now g is the 10. So look at this and this cancel out. This is the 4. Therefore, u equal to, this is the 4g by 3. Now g is the 10. Now g is the 10. So this is the 40 by 3. Look at this option. This is not correct. This is not correct. This is the correct option. Okay. Now look at this question number 23. The figure shows a velocity time graph of a particle moving along a straight line. Identify the correct statement. Look at this. The particle starts from origin. Yes, it is the correct option. B. The particle crosses the initial position at t equal to 2 seconds. No. Look at this. Yes. Look at this. At t equal to 2 seconds, the area of this region is equal to area of this region. So displacement is equal to 0. So particle again reaches the initial position. The average speed of the particle in the first interval from t equal to 0 to t equal to 2 seconds is 0. Okay. Look at this. Displacement 0. So average velocity, this is the displacement by time, this also 0. D, all of the above. Okay. A ball is thrown vertically upward from the ground and a student grazing the window sees and moving in the upward past 10 meter per second. The window is at a 15 meter above the ground. The velocity of the ball 3 seconds after it was projected from the ground. Now look at this. We have to calculate the initial. Now we have to calculate the initial velocity of projection. Look at this. At the window, velocity becomes 10 meter per second. So time taken by the ball to reach the final point, time taken by the uh, time taken by the ball to reach the highest point from the window, this is the velocity by acceleration. Acceleration is the 10 meter per, so this is the 1 second. Okay. And height ascent, look at this, and height ascent, this is the u square by 2g. So this is the 10 square by 2 into 10. So this is the 5 meter. Now the ball projected 15 meter below the window. Therefore, so total height ascent, this is the 5 meter plus this is the 15 meter. So this is the 20 meter is the total height. Now total time of flight t equals to, this is the 2 into root over 2 h by g. Look at this. So this is the 4 second because here h is equal to 20. So correct option of velocity is 10 meter per second in downward direction. Look at this question number 26. A body starts moving with a velocity v naught equal to 10 meter per second. It experiences a retardation equal to its velocity after 2 seconds is given by. Look at this, you know retardation, that is dv by dt, this equal to negative sine of 0.2 v square. Now look at this is the v to the power minus 2 dv, this equals to minus 0.2 dt. Now integrating. Look at this, the boundary condition is when t equal to 0, the velocity is 10 meter per second. So look at this is the 0 and this is the 10 meter per second. This is the t and this is the velocity v. Okay, and this is the and this is the t equal to 2 and this is the velocity v. Okay, now look at this v to the power minus 2, that means v to the power minus 2 plus 1 divided by minus 2 plus 1, limit of integration is the v and this is the 10. Look at this is the negative sign of 0.2 into 2 minus 0. So this is the negative sign of 0.4. Okay. Now look at this, from this expression here negative, this negative and this negative cancel out. So look at this is the 1 by v. Look at this is the v10, this equal to 0.4. So 1 by v minus 1 by 10 equals to 0.4. Therefore, look at this, 1 by v equal to 0.5. Therefore, v equals to 2 meter per second. Look at this, option A is correct. Now question number 27. Two trains are moving with a velocity v1 is equal to 10 meter per second and 20 meter per second on the same track in opposite directions. After the application of brakes, their retardation becomes 2 meter per second square and 1 meter per second square respectively. Then minimum distance of separation between them, between them to avoid the collision. Now look at this, the minimum distance S1 plus S2, this equals to, this is the U1 square by 2a plus this is the U2 square by 2a. Look at this, U1 means 100, now look at this, U1 square means 10 square means 100 divided by 2 into 2 plus this is the 20 square plus 2 into 1. So look at this is the 25 and this is the 400 by 2. So this is the 200. Therefore, minimum distance is the 2 to 5 meter. B option is correct. Okay. Now look at this question number 28. Two identical balls are shot upward after another in an interval of 2 seconds along the same vertical line with same initial velocity 40 meter per second. The height at which the ball collides. Now at the point of collision, the height ascend by both the balls is h. So look at this. This is the first ball for 40 into t minus half into g into t square. For second ball, this equal to 40 into, this is the t minus 2 plus minus half into g into t minus 2 the whole square. Okay. Now equating these two equations, we have to calculate t, and if we find t, then we can easily calculate h. Okay. Now, first of all, t. So look at this. This is the 40t minus 5 into t square. This equals to 40t minus this is the 80 minus this is the 5 into t square minus 40 plus 4. Okay. Now look at this. This is the 40t cancel out. Now look at this. This is the minus 5t square equal to this is the minus 80. This is the minus 5t square. This is the plus 4 into 5t. 4 into 5t, and this is the 4, means this is the minus 20. Now minus 20 and minus 80, this is the minus 100. This and this cancel out. So look at this. This is the 20t equals to 100. Therefore t equals to. So look at this. This is the 20t equal to 20 80 100. So this is the t equal to 100 by 20. Therefore, this is the 5. If so, we can easily calculate h from this equation by putting the value of t. So look at this. This is the look at this. This is the h equal to 40 into 5 minus half into 10 into 5 square. Okay. So look at this. This is the 200 minus this 5. 5 into 5 square 125. Therefore 75 is the height at which they collide. So option B is correct. Okay. 9. Now 29. A particle is projected vertically upward and reaches the maximum height capital H in time t. So look at this. H is equal to this is the half g t square. Okay. Now look at this. Now look at this. H be the height. Now look at this. H be the height ascended by the particle in time t. So t be the also be the time of fall. So in time t the height fall h, and in capital T minus small t height fall, this is the half g into t minus t whole square. So height ascend in time t, this is the h minus half g t minus t whole square. Okay, option D is correct. Now question number 30. A particle moves along a curve y equal to x square by 2 where x varies with time where x varies with time as x equals to t square by 2, where x and y are represented in meter and t in second. At t equal to 2 seconds, the velocity of the particle. Now look at this. Here y becomes, look at this. Here y equal to, this is the x square by t. So this is the t to the power 4 by 8 is the y. X is the t square. So look at this. This is the velocity in y direction, y dot. This equals to 4 t cube by 8. So this is the t cube by 2. Now velocity in y direction after the time t equal to 2 seconds. So this becomes 2 cube by 2. So this is the 4 meter per second. No problem. Now velocity in x direction x dot. This equals to, this is the 2t by 2. So this is the 2 meter per second as t equal to 2 seconds. Therefore, velocity becomes 2 I cap plus 4j cap after the time 2 seconds. Okay. Now question number 21. If the displacement of a particle varies with time t equal to root x equal to t plus 3. So look at this. From this condition we can write x equals to t plus 3 whole square. Okay. Now velocity of the particle inversely proportional to t. Now look at this velocity. This is the x dot. This is equal to 2 into t plus 3 into 1. So this is the velocity, the 2t plus 6. Velocity of the particle varies with linearly time t. Okay. Now question number 32. The graph describes an airplane. The graph describes an airplane acceleration during the takeoff run. The airplane's velocity when it lifts up at t equal to 20 seconds. Now look at this here acceleration time graph. Here acceleration increases from 3 to 5. Okay. During this acceleration, the change of velocity equal to area of this graph. So area of this graph represents the change of velocity. What is the change of velocity? Look at this. This is a trapezium. So area of this trapezium, this is equal to 3, this is equal to 5. So area of this is the 3 plus 5 divided by 2 into 10. Okay. So 40 meter per second is the change of velocity. Okay. Therefore velocity reaches from 0 to 40 meter per second. Okay. After that, after that, the after that the velocity increases from 40 to linearly. So this is the 40 plus a is the 5, p is the 10. Okay. So this is the 90 meter per second is the velocity of the plane. Okay. This option correct. Now look at this question number 33. A particle moving in a straight line has a velocity displacement equation. Look at this v equals to 5 into root under a plus x. Where v is in meter per second, s in meter, select the correct option. Now look at this here v square equal to, this is the 25, 1 plus s. Now if we differentiate this with respect to x, so this is the 2v into dv by ds. This equals to 25. So look at this here acceleration v d by ds constant and this equal to 25 by 2, that is 12.5. Now what is the option? Particle is initially at rest. No, we can't say the particle is initially at rest. The initial velocity of the particle is 5 meter per second. No. Initial velocity of the particle, that is when s equals to 0. Look at this. Look at this, when s0, the velocity, yes, this is correct. Initial velocity of the particle is 5 meter per second. And the particle has a constant acceleration of 12.5 meter per second square. Yes, constant acceleration of 12.5 meter per second square. That is 25 by 2 is the correct option. The particle moves, the particle moves with a uniform velocity. No. None of the above. So here option B. The particle initially at rest. Initially means s equals to 0. Look at this, when s equals to 0, velocity v equals to 5. So this option is incorrect. The initial velocity of the particle 5 meter per second. Okay, correct. And the particle acceleration is 12.5 meter per second square. Okay. The particle acceleration, look at this, from this condition we can calculate acceleration. Here v square is equal to, this is the 25, 1 plus s. Now if we differentiate v square with respect to s, we get 2v into dv by ds. This equal to 25. Therefore v dv by ds equals to 25 by 2, that is 12.5 meter per second square is the acceleration of the particle. Okay. So B option is correct. Question number 34. A particle is thrown upward from the ground. It experiences a constant resistance force which can produce a retardation of 2 meter per second square. The ratio of time of ascent and time of descent. First of all, we have to calculate time of descent. During descent, g downward and a upward. So net acceleration, this is the 8 meter per second square. So time of fall t2 equals to root over 2h by 8. Okay. And during upward journey, in the time of ascent t2 equal to, this is the 2h divided by 10 plus 2. So this is the 12. So this is the 12. Therefore, T2 is to T1. Time of ascent is to time of descent. So this is the 8 is to root 8 is to root 12. So this is the root over of 2 by 3. Okay, understood? Next. Look at this, a river is flowing from west to east. Look at this, river flowing from west to east. This is the west to east. Okay, with a speed of 5 meter per second, with a speed of 5 meter per minute. A man can swim in still water with a velocity of 10 meter per second. In which direction should the man swim so as to take the shortest possible path to go to the south? Now, from this point to this point, the person must move along this direction. Suppose this angle theta. So, component of velocity 10 meter per second along this direction, this is the 10 cos theta. Okay, if 10 cos theta is equal to velocity of the stream 5, then cos theta equal to 60 degree, sorry, then cos theta equal to half, so theta equal to 60 degree. So person in this condition, the person reaches the directly south. Okay, no problem. Yes, this option correct. 30 degree west of south. Look at this. This is the 60 degree. So this must be 30 degree. Okay. So option B is correct. For many thanks for watching this video. To score better in the entrance examination and learn physics easily, subscribe my channel.